Okay, so this activity is all about life history strategies. So I had you start out with this game, and I'm going to do it in words so you can see. It actually, so if you haven't tried the game yet, you really should try the game before you watch this. But it's showing that you get 3 energy points to start out with, and these are the weeks of your life. So you must be a bug or something, and you have 3 things you can put the points into: growth, maintenance, or reproduction. So growth is getting bigger, maintenance is staying alive, and reproduction is offspring. And so if I have these 3 here, I have to put 2 into reproduction, or I'm into maintenance. Excuse me, I have to put 2 into maintenance, or I'm gonna die. That leaves me 1 point left over, so I can either grow or reproduce. If I grow, then those points get combined into the next week. So if I choose to grow, for instance, I put the 1 there, then this week I get 4 points, but I have 0 babies, right? So I'm going to put 0 here, so I have a 0 offspring. But now I have 4 that I can put into things, and so I'll put 2 into maintenance, and that leaves me 2 left over. Oh, I can put it in the middle. And so I could either grow or reproduce. So the way it has you try to see if you can get 48, well, the key, obviously, to that is to never reproduce, right? And then you'd have 6 here, because 4 plus 2 is 6. I have to put 3 into maintenance, and then I'll put the other 3 into growth. Again, we're at 0 here. And then we would do 9 now, right? And I'm going to put 3 into growth. I'm sorry, into maintenance, and 6 into growth. And that again is 0, 0. And then we have 15 here. And so I can put 4 here and 11 into growth and not reproduce. And then we have 26 here. And then I can put, not 22, but 4 here, which leaves 22 here. Wow. And we haven't grown again. And then you can end up with 48 points here. And remember, if you know this is the end of your life, which I use "know" in quotes, right? Because organisms don't know. But those that tend to terminally invest have those genetics and tend to do that behavior. And so they don't pay their maintenance fee for this last year, and they don't grow, and instead they put it all into reproduction. So technically you could get 48 offspring. But again, the problem is that what if you died at the end of week 6? Then you got 0 and you're totally unfit, right? So it's a game, and it really is a game. But again, they're not consciously choosing this. They are, it's the behaviors that get selected for depending on the environment. All right, so that's kind of what that game shows you. And so we talk about terminal investment. So terminal investment's a bad idea, though, if your environment is really risky, right? And we kind of use that term stochasticity. This is sort of the randomness or the chance that you're going to die. So if your environment is really stochastic, it's not a good idea to terminally invest. But if you're in a very stable environment where you have very few predators and you're likely to live for a long time, then you're going to wait to reproduce and reproduce as much as you can. So then we use these burying beetles, and we have these 2 populations, and you can see they did this in the laboratory. They took them from 2 different places, and you can see that the blue beetle, obviously it's not blue, but anyway, the blue beetle reproduces sort of slow and steady over time, with going lower each time, right? Because reproduction takes energy, and so you can't put energy into growth, and so you're going to eventually stop reproducing. Whereas the pink one seems to throw all of its energy mostly into the first bout of reproduction, and then gets drastically lower till it dies. And so you would guess that, overall fitness, beetle 1 has more babies if they all live to 6 weeks. But if they die early, beetle 2 is more fit, the pink one. And so looking at this figure, you can sort of guess that the pink one probably comes from a stochastic environment. So the trait of throwing all your energy into reproduction early is selected for. And so then we looked at, like, where do you put your energy? Do you do very few but large offspring, or you do a whole bunch of little offspring? And it depends on your environment, right? If most of your babies are likely to die, if there's like high predation, then you're going to produce tons of babies. But to do that, you either have to be bigger or your babies have to be littler. So generally, to get bigger takes time. And if your environment is really stochastic, you're not going to be very big when you reproduce. And so you're going to create lots of little tiny, tiny babies. Right? Whereas if you have a stable environment and the competition really is more carrying capacity related, meaning you're competing with people in your own species, like competing for mates or competing for space, you're more likely to produce really large offspring and few of them because your offspring have to compete with each other. Okay? And so we have this little figure down here. It's kind of small. But if you have really high fecundity, lots and lots of birth, because you have low survivorship, you're on this left side of the curve, and we call them R-dependent. The higher your growth rate, the more likely you are to succeed, right? Versus on the right side, where you're more likely to survive, and so therefore you have really low fecundity, low birth numbers of offspring. And that's because you're competing with each other. You have a very stable environment. You're sort of at the top of the food chain, and you're going to live a long time. So we see kind of anything in between there, but those are the two extremes. Okay, so that's what you should have learned from this activity.